about soil health at the RAIN project.
I'll advance your slides.
So the objectives of my project are to think about the rain treatment effects on soil health broadly. So we want to observe the differences in microbial community and functionality via PLFA and extracellular soil enzyme analysis. Then look at soil chemical properties such as carbon and nitrogen, phosphorus, potassium, magnesium, calcium, and pH to get an understanding of the chemical environment the microbes are inhabiting in the soil. And then we want to compare these treatments to the baseline samples taken 2 years ago. And then I have just a quick definition of soil health in case anyone hasn't encountered that before. So it's basically the capacity of the soil to function as a living system and sustain plant and animal productivity, enhance water and air quality, and promote plant and animal health. So in order to meet these objectives, we're going to analyze the PLFA, which is the phospholipid fatty acid biomarkers, which are able to tell us microbial biomass, and then also the biomarkers are able to show us different groups, and we can develop things like bacterial to fungi ratios and understand the microbial community and if the treatments have shifted it. And then the extracellular enzymes, we're looking at 3 different enzymes. I'm not going to go through the names, but one looks at the deals with carbon metabolism, phosphorus, and nitrogen. And then we're also doing those chemical analysis, but those are going through the soil testing lab, so I'm not doing those. And that's for those things I mentioned previously, gravimetric water content, and comparing those to the baseline from 2 years ago where we have the same analysis. And we're only looking at 2 depths, 0 to 5 centimeters, 5 to 15 for each plot. And there's 4 of each of the treatments. So that's 32 samples total. And we're doing a subset of treatments 1, 2, 8, and 12. So these are just some quick pictures. So this is treatment 1, which is the wheat and fallow rotation. This is treatment 2, the adaptive forage, wheat and summer crop fallow rotation. This is treatment 8, the intensive wheat and summer crop. And this is treatment 12, the dual purpose semi-intensive wheat and triticale alternating summer crop and fallow. So you can see in those pictures, there were different levels of residue and things like that. And that'll be important when we think about soil health. So one of the hypotheses is that increasing the intensity, so the crop diversity and number of crops, will increase or change the functionality of the microbes, which we can see in the different levels of the enzymes, which allow us to see basically what the microbes are doing, and then might increase microbial biomass, which we'll see in the PLFA, and alter the community structure. And that's related to the increase in soil carbon, we think would be related to increasing the number of crops. And also we think that perhaps the microbial community structure and functionality will change compared to the baseline over time. So comparing the treatments and then compare those to the baseline as well. And then thanks to the team that helped me sample on Monday.